Hello, people. Good evening. It is around 6 o'clock my time. And tonight, this evening, we are going to go over section 12.1 and 12.2. They both involve areas of three-dimensional shapes. So if I had something like a shoebox, if I had something like a metal box right here, I might be interested in the area of this thing. So this particular box is a prism. It has, what makes it a prism is that it has two parallel and congruent bases connected by rectangles. Now I could say that these are the two parallel and congruent bases, or I could say that these are the two parallel congruent bases, or I could say that the front and the back are the two congruent parallel bases, although technically this one is doesn't have a front, but you couldn't tell that. So for a rectangular prism, it really doesn't matter which ones you call the bases and which ones you call the other sides, kind of the sides on the sides. The word for side, of course, is lateral, so the lateral faces. There are either bases or lateral faces, which are all rectangles. Here is a coaster, which is a rectangular prism. So it has very thin lateral faces and nice big thick bases. Okay, so really to find the surface area, sometimes called total surface area, sometimes I think the book has another weird term for it. We'll call it total surface area or just surface area. That is the lateral area plus the area of the bases, of which there are two. So let's figure out a nice quick way of finding the surface area and the lateral area, and also develop a system here for not confusing one and the other. Ooh. And boom. Okay, so in a rectangular prism, it doesn't really matter which side we call the bases. Base does not mean bottom, so I'm going to make the left and the right the two bases. And let's put in some numbers here. Let's put in a 10, a 4, and perhaps a 20. So the area of my base, and I'm going to do big B for area of the base, is, well, that's a rectangle, is base times height. Okay, so the big B is the area of the two-dimensional shape, is the base, and the little b will always be that one-dimensional thing, the length of the base. And this is the height of the base. Again, those two things are perpendicular. It doesn't matter whether it's 4 by 10 or 10 by 4, whether you call 4 the base of the base or the height of the base. Either way, we're going to get 40. Now, for the lateral area is the area of all four of these rectangles, the one in front, the one in back, which are congruent, the one on top, the one in the bottom. So let's see, this length here is a 4 by 20. 4 by 20. This length here is a 10 by 20 plus 10 by 20. The one in the back is another 4 by 20, and the one on the bottom is another 10 by 20. What you should notice is that all of these have a 20 in them. Well, let's factor it out. So 20 times 4 plus 10 plus 4 plus 10. Now I know what 4 plus 10 plus 4 plus 10 is. It's 14 times 2. It is 28. But that's not really what I'm interested in when I ask the question, what is 4 plus 10 plus 4 plus 10? The answer that I am looking for, it is the perimeter of the base. When I say perimeter, I'm referring specifically to perimeter of the base. So I'm going to say that this is 20 times perimeter. Well, what is 20? 20 is what I'm going to refer to as the big H. Well, little h is the height of the base. Big H is the height of the prism. The height of the prism is the distance between the two bases. Remember, base do not have to be top and bottom, so H times P or P times H. My lateral area of any prism is perimeter of the base times the height. Lateral area is perimeter of the base times the height. My surface area for any prism, whether it's rectangular or not, and we'll do a non-rectangular one in a minute, will be my lateral area plus the bases. Well, there are two of them. So that's all there is to it for any prism. Let's do another example here. Let's do a triangular prism. In fact, we'll do a right triangle. So we'll pick one of our favorites, A3, 4, 5, and I'm going to draw the same thing over a little bit, and usually I'll do it below. I'll just draw segments which connect all the corresponding parts. That one I'm doing dotted, and it kind of gives that three-dimensional feel that you have to look through it. I'm going to shade my two bases. They are not the top and the bottom. In this case, they look like the left and the right. And I'm going to say that my lateral area equals perimeter times height. Well, the perimeter is 3 plus 4 plus 5. The perimeter is 12. The height we didn't put in. Let's make it 10. The height is the distance between the two bases. Nice easy number there. And my lateral area is 120. I might be interested in the lateral area of something if I were going to paint the walls, but not the ceiling. Well, what if I want to paint the top and the bottom two, the floor and the ceiling, the two bases? I will say that my surface area equals my lateral area plus 2b. Well, what shape are the bases? In this particular case, they are triangles. We did rectangular prisms. We will do hexagonal prisms, trapezoidal prisms, kite-based prisms, prisms with bases which aren't a shape that we have necessarily talked too much about. That is okay as long as you can find its area. So I'm going to say it's lateral area plus 2. In this case, it's 1/2 little b times little h, area of that triangle. So I've got 120 as my lateral area, plus 2 and 1/2 cancel out, and the base and the height are that 4 and that 3, plus 12. My surface area is 132. Okay. Again, we could do this for any type of prism. It does not have to be either a triangular or a rectangular. Okay, let's move on away from prisms and let's talk about pyramids. So I'm going to draw a square pyramid, which means that the base is a square. So that doesn't look too much like a square, but if you draw a square, then that means you're looking straight down at it, and that's not too interesting. So I drew kind of a rhombus looking thing, picked one point above it, and then played connect the dots. If I were at school, I would have then erased this a little bit. If I had drawn it on the marker board, easy enough to do. Well, it's a square base. We'll say it's 10 and it's 10. This time, let's put in a slant height of, I don't know, we'll make it 12. So the surface area is the lateral area, the area of all the sides, plus it only has one base. The lateral area is again perimeter. Well, it's not perimeter times height, and it's not perimeter times slant height. The cursive L is slant height, because these aren't rectangles. They are all triangles. The area of the triangles is 1/2 base times height. So 1/2 perimeter times slant height if I add up all their bases, plus the area of the base. Okay, so let's see what we have. 1/2, the perimeter of this thing is 40. The slant height is 12. It's 20 times 12, that is 240, plus the area of the base. The base is a square, so it's just s squared plus 10 squared. 240 plus 100, that is going to be 340 as my total surface area. Lateral area 240, base 100, total surface area 340. Okay, let me pause you for a moment. I'm gonna just check to make sure that there's nothing that I am missing. I feel like we got most of it, but there's something which we should review, and that is how to find the slant height given some other information. So let's draw another one of these. Let's make this a square pyramid with a side of 8. And what if this time, instead of the slant height, I gave you the actual height, also called the altitude? We'll make that 10. Well, I would draw in this apothem of the base. Well, it's a square, so the apothem is half of the length of the side. And to find my slant height, I might have to bug my good friend Pythagoras here. A squared plus b squared equals that c squared. 4 squared plus 10 squared equals c squared. 16 plus 100 equals c squared. And c squared equals 116. That is 2 root 29. And although that's not a nice number, sometimes it will be, sometimes it won't be. So if I were to find the lateral area of this guy, once again, that formula was 1/2 perimeter times slant height for any pyramid, things which have one base and come to a point. That is 1/2 the perimeter of the base, 8 times 4, 32, times that slant height, 2 root 29. The 2 and the 1/2 go away. My answer is 32 root 29. If I want to go a little bit above and beyond just the lateral area, I could say, oh, well, the total surface area, and I looked in the book, it does call it total surface area, equals my lateral area plus, I only have one base, so that's 32 root 29 plus 8 by 8, 64. Those are non-like terms, so they can't be added, but there it is. All right, I'm going to wrap things up before my small children come and attack, and I wish you a happy Friday and weekend. All right, bye guys.